The topic for today is waves. Each wave has a specific wavelength and a specific frequency. Now, my question to everybody is, what do you think will happen to the frequency if the wavelength decreases? If you said that the frequency will increase, you are correct. When we shorten the wavelength, our frequency ends up increasing. And the same could be said vice versa. If you increase the wavelength, the frequency will decrease. So they are inversely proportional. Now, each wave has a speed, and the speed is equals to the wavelength times the frequency. Any type of speed is measured in meters per second. That means that the wavelength has to be converted into meters, and the frequency has to be in hertz, because hertz is the same as 1/second. And there are specific types of waves that we talk about, and those are waves that come from light. And for that one, instead of just using speed, we have the letter c, which is a constant, and it is the speed of light. C has a value of 3.00 times 10 to the 8th. That means that whenever you have a light wave, you can use that value to solve for either the frequency or the wavelength of that wave. Now, just like every wave has speed, they also have to have some type of energy. And for that energy, we have this equation where energy is equal to Planck's constant times the frequency. And Planck's constant has a value of 6.63 times 10 to the negative 34 joules times second. Okay, now if we have a problem where they don't give you the frequency and they give you the wavelength of the light wave, you could use this equation to solve for the frequency and then plug it into this equation to solve for the energy of that wave. Now, there are other types of energy out in the world. Those are released by electrons. And to find the energy for the ones that the electron release, we use a different formula. But let's talk about that for a minute. So every element has electrons, and those electrons exist in energy levels. So if we look at this model here, there's an electron here in the third energy level, and that one moves down to the first energy level. So it started at 3 and it ended at 1. Now that energy that gets released by electron is called a photon. And that photon also has a specific wave, and it is that wave that we can see because of its wavelength. Now, to solve for the energy that gets released as a photon, we use this equation, Rydberg's equation, that says that the energy is equals to Rydberg's constant, and then times 1 over the initial energy level minus 1 over the final energy level. That's what each of those means. And Rydberg's constant has a value of 2.18 times 10 to the negative 18. Let's practice this equation. So say we have a problem, and the problem says, what was the amount of energy emitted as a photon by the transition of an electron from energy level 4 to energy level 2? So our initial energy level is 4, our final is 2. So let's just plug it into the equation. 2.18 times 10 to the negative 18 joules times 1 over 4 squared minus 1 over 2 squared. And then we'll get this, 2.18 times 10 to the negative 18 times 1 over 16 minus 1 over 4. That gives us 2.18 times 10 to the negative 18 times negative 3 over 16. And our answer is 4.0875 times 10 to the negative 19. And it's supposed to be negative. I just kind of forgot that. Just make sure that it's negative because it is the energy that is released. And this is all for energy and waves in particular. I hope this video helped you all to understand this a little bit better. Thank you.